Hello everyone, I am back as I promised. Today we are going to learn about vertical projectile motion. Vertical projectile motion. This is the topic we are going to be learning about, but specifically I'm going to be focusing on what? Graphs. We're going to be looking at graphs today. When we talk about graphs, I hope you remember grade 10 and 11. We spoke about straight line graph. We learned about the straight line, and then we learned about parabola. These are the graphs we were talking about, obvious exponential and hyperbola. Remember the straight line, the equation is y is equal to mx plus c, and this one is y is equal to ax squared. So these are the two graphs that we know from mathematics. So this m, it stands for what? Gradient. This m stands for gradient. So here in vertical projectile motion, you know, friends, okay, ma I said is gradient. If the gradient is greater than 0, so the graph, it will be like this. If the gradient is less than 0, you remember the graph will be like that. So we have to take these things to what? Vertical projectile motion, where we talk about velocity versus time graph. This gradient, it represents acceleration. This gradient represents acceleration. So if your acceleration is negative, in other words, if you choose downwards as negative, this is the type of the graph you are going to see. If you choose upward as positive, this is the type of the graph you are going to see. Now, we come to parabola. Therefore, if a is greater than 0, you know that the graph will be like this. If a is less than 0, you know that the graph will be like this. These are the two graphs. So this A is talking about acceleration again. It talk about acceleration. If you choose downwards as positive, this is the type of graph you must see. If you choose downwards as negative, this is the type of the graph that you must see. I hope we are together there. Okay? Now, let's start. Velocity versus time. Velocity versus time graph. What do you expect in velocity versus time graph? Okay, let me just draw a simple graph. I already spoke about this type of shapes. Let's just have a graph like this and interpret it. What does this mean? So this point, remember from straight line, this C represent what? Y-intercept. So every time the y-intercept is here, where x is 0. So remember x, this line, velocity versus time. That means here you're going to have your velocity, and then this one is going to be what? Time, measured in seconds. Velocity, meter per second. So when you look at this graph, my learners, you see that this is the y-intercept, where t is 0. T is 0, it talk about initial time. And then since t is 0, therefore this one is what? Initial velocity. Every time where the graph starts on the y-axis. So we call it what? Initial velocity. Always is like that. And then this point here, this is t is equal to 0. This point is the what? Is the maximum height. Don't forget, this is the maximum height. Or if your graph starts here at 0, so that means this is the initial velocity 0, but this t is 0 because the graph, it went upwards and it reached the maximum height. You see? So this is the velocity versus time graph. You must interpret it like this. Now, when I come to position, let me just create a space here. When we come to position versus what? Time. Position versus time graph. position versus time graph. Okay, this is so simple, learners. If you choose upward as positive, that means this is where the graph is going to be like this. If you choose downwards as negative, the graph will be like this. You see, this is t, this is t0. Here we get our height. Here we get our what? Our time. When this ball was projected upward, it reached the maximum height. So the time it takes to reach the maximum height is this one. And then when it reached the maximum height, it came back to the point where it was projected. You see? This is how we need to understand this graph. Okay, look, let's say a person was on top of the building. If the person is on top of the building and then you throw the ball upward, it reached the maximum height and then it came to the level at which it was projected, but it passed and go to the ground. That's why your graph, it will have to come down like this. If the top of the building is being taken as the what? As the zero reference. Don't forget about these things. Now, let me just get a space. Let me use this one. Example, let me just give you a small diagram like this. And then the ball was thrown up and then it come and hit the ground. This is just an example. So draw a position versus time graph. Therefore, the first thing, you will choose your direction. You choose upward as positive. So that means this is your what? Your graph. Let's say, for example, this is 50 meters, and then from here to upwards there is 3 meters. This is just an example. Like I said, draw the position versus time graph using the top of the building as zero reference. What does it mean? Okay, before we draw the one for zero reference, let's just draw this one without that condition. That means you are going to draw it like this. Instead of starting at 0, remember the height of the building is what? It's 50. You put your 50 here, and they need to be what? 53. Why 53? You are adding 50 plus 3, it reaches the maximum height. So it will come here, reach the maximum height, and then it goes down like this. 0 is the ground. But if I say the top of the building is 0 reference, take it as 0 reference. That means you're going to come here and you put your 0 here, the top of the building, that means it is here. So the graph will go up and come back. Remember here, we said it's 3. From here up is 3. But we're going to go where? Down. This is minus what? 50. Because you took the top of the building as 0 reference. Don't forget, this is very, very, very simple. And then when we talk about position versus time graph, like I said, so that you don't forget. In position versus time graph, like I said, if you have a bounce, you do it the way it is. If I'm having a building like this, and this is the ball, was thrown up, it come down to the ground and bounce. You see? Even when you draw the graph, you have to draw it the way it is. That means you are going to come and draw it, you see? The top of the building, then it go up, hit the ground and bounce. If the top is taken as 0 reference, therefore, it means that you are going to come and draw it like this. It will go up and it come down and bounce. So this is so simple. Very simple. Okay? Let's have another space so that I can be able to assist you. Acceleration versus what? Time. Acceleration versus time graph. Likewise, like I said, this graph, this is 0, this is positive 9,8, and this is negative 9,8. If you choose upward as positive, the graph, you draw it like this. If they say draw acceleration versus time graph, if I give you a question and say draw acceleration versus time graph, And then if you take downwards as negative, therefore this is where you draw the graph. That's acceleration versus time. I hope we are together there. So I prepared some few questions for you. Let's try to go through these few questions. As you can see here, these are the questions we are having. These are questions we are having. As you can see, this is example number 1. Ball A was projected vertical upwards from the top of the building and reached the maximum height after 4 seconds. On its way down, the ball passed the top of the building and hit the ground. The velocity of the ball at which it was projected with is 15 meters per second, and the height of the building is 30 meters, as indicated below. I hope you can see this diagram. I hope you can see this diagram clearly. This is ball A projected upward, hit the maximum height, then it come and pass the same level. I hope you remember when a ball go up and reach the same level, the same time it take to go up is the same time to come here. The velocity at which it was projected here is the same as this one here. So, and then it come and hit the ground. Now, the first question, define the term free fall. Define the term free fall. So I hope you remember that this is the motion at which the only force acting is the force of gravity. This is the answer for the free fall. When you say define the term free fall, is the motion at which the only force acting upon that object is the force of gravity. Now, let's proceed. Let's go to the next question. Determine, we're going to calculate here, the maximum height at which the ball reached from the top of the building. Now we are looking at the maximum height. I hope you remember, my learners, that when we talk about, we're going to try to answer this one. We'll write solution. Okay, we are on what? 1.2.1. We want to calculate the maximum height. Remember, the velocity of the object at the maximum height is what? 0. You see, because it is stationary, it is not moving. The information we are having is the initial velocity, which is, okay, before we talk about anything, let's choose our direction. It's very, very much important. So which one are we going to choose? Let's say maybe, for example, upward. Upward as what? As positive. We're going to we chose upward as positive. Okay, that means initial velocity is 15 meters per second. Your acceleration, because the object is going up, is negative 9.8 meters per second what? Squared. And then the velocity here, we are going to take it as the final velocity. It's 0, you see? So we are going to check a formula that is having all these values that we are having. So we found out that the formula we are going to have is what? V final. Remember, we also have time there, 4 seconds. So we're going to use V final squared is equal to V initial squared plus 2A change in what? Y. This is 0 squared is equal to 15 squared plus 2 into minus 9.8 change in what? In Y. So these are the things that we are replacing. Like I said, this is what we are having. We replace the final velocity here. We replace the initial velocity here. Acceleration, negative 9.8. This is what we have. Now we are looking for the change in Y. So change in Y is equal to, let's get our calculators. Let's get our calculators and then we start pressing. Let's get our calculators, then we start pressing the values. Now we are going to solve. If you take this one this side, it will be a negative number, so this is 15 squared. It will give us 225. You see, it will give us 225. Then it will be negative. Therefore, you divide it by negative 2 into, or rather, we divide, let's just do it quickly. Open bracket 15 squared. Then we're going to divide it by 2 into negative 9,8. You see? So remember, this 15 is negative. You see, we get this negative number. It's